So we can do the same thing for a parallelogram. A lot of people get confused and think that a parallelogram can be length times width, and they measure, they see it, think it's a quadrilateral, and they measure along this and call this green part the length, and then they measure up this and say this is the width. Well, that does not work for a parallelogram like this. It only works, length times width only works for a parallelogram that is a rectangle, so with 4 right corners. So what are we going to do to prove this formula? Well, here's the base, and here's the height. So how do we make sure that we can see this? Well, I'm going to just take, because I know I can move area around, and I'm going to cut off this piece, and I'm going to pull it over here. So now I've taken and I've gotten rid of this part, and what I have left is a rectangle that is this high, or h high, and here's my base. So now I've created a situation where my parallelogram now looks like a rectangle, and I can use the base times the height as my length times my width. Let's take another look at those triangles. So how can we find the area of this triangle using the formula 1/2 base times height? Well, the one thing that we did on the previous page is we boxed it in on both sides here, and I'm going to draw this second box as a different color. All right, so we can see that by doubling this half of the triangle and also doubling this half of the triangle, we've created a rectangle that has the area of base times height. But we've doubled the overall area. Basically, we've created another one of these triangles. So to get the actual area, we have to take 1/2 of the base times the height to be left with just the area of the original triangle that we see in purple. So basically what we've done is we've doubled the triangle, found the area of double the triangle, and then taken 1/2 of that. So we can use this whole idea of breaking things up and using the, now that we've proved the formula for triangles and for rectangles and for parallelograms, we can now use this to find the area of other figures. So how do we do that? Well, we can do this in several different ways. There are many ways to show how to figure out these parallelograms. So I'm going to start here by going and drawing a parallelogram. All right, so there is my parallelogram, and it has a base of 1, 2, 3, 4, 5, 6, and a height of 1, 2, 3, 4. So I know that this parallelogram right here has an area of 24 square units. I also know that I've got a little triangle here. So I know that this triangle has a base of 1 unit and a height of 2 units. So that means that it has an overall area of 1/2 1 times 2, base times height. So that is going to be equal to 1/2 of 2, which is 1 square unit. And we'll color that in as orange. What else do we have? Well, we can take and divide this into another triangle. And so we know that this has a base of 1, 2, 3 and a height of 2. So 1/2, 3 times 2 is going to give us our area here. So this is going to be 3 square units. Shade that in with a different color. Okay, so now we have left this trapezoid, but we can't use trapezoid because we haven't actually shown how to find that formula. But I can cut off a triangle here and a triangle here, and I can actually move this triangle over here. So I am going to get a total rectangle that is 2 units by 2 units. That means that we now have a box right here, remember that's gone, of 4 square units. So now, to find the total area, we end up with adding 24 square units with 1 square unit. So this pink parallelogram and this triangle, and then 3 square units. So we've got 24, 25, 28, and then this square, which is 4 square units. So we've got 24, 25, 28, and then 32 square units. Okay, well, does that make sense? So let's erase all of this except for our total. So now we've erased all of that. By breaking up in pieces, that's one way to go. And we came up with 32 square units. But let's do another thing. Let's take and box this entire shape into a rectangle. So we know that its height is 4 units and its length is 11 units. So we know that the area of this entire rectangle is 11 times 4, or 44 square units. So 44 of those little squares. But we've added in these triangles. And notice each one of these triangles is 2 units long and 4 units high. See, 2 units long and 4 units high, 2 units in the base and 4 units high. And we need to actually find out what the area of these are and subtract them from 44. So that means that we have 3 triangles that have the area of 1/2 times 2 times 4. So 1/2 the base times height. So that's going to be 4 times 3, which is equal to 12. So this is what we have to take away. Come down here and we're going to take the area of the big rectangle and subtract the area of these 3 triangles. And we end up with the same result. 44 square units minus 12 square units is 32 square units. So there's many different ways to figure these out. If you didn't want to do it in a big rectangle, you could have divided this into a square and a rectangle. But the whole point is that we can create a rectangle and then subtract, or we can divide up this into many different parts. All right, so let's look at this hexagon. We don't know the formula for the area of a hexagon, but we're being told this has a length of 10 centimeters, and this has a height of 8 centimeters and 6 centimeters. I'm going to box this in, and when I do that, because I know this is a rectangle, I know that this is now 8 centimeters high, and this is 6 centimeters. And that means that if this is, all the side lengths are 10, so every single one of these has the same situation going on. We can now find the area of this rectangle. So we've got 6 centimeters, 6 centimeters, that's 12 plus 10. Remember it said all side lengths are 10. So we know it's 22 long and 16 wide. So we're going to take 22 times 16, and these are centimeters, right? So that's going to give us 352 square centimeters. But now remember, we have to go back and cut off these triangles. Notice all these triangles are exactly the same. So we could actually, instead of figuring out what all 4 of these triangles are, we could flip them together and subtract off 2 rectangles that are 8 by 6. So basically we're going to take 352, which is our overall rectangle, square centimeters, and we're going to subtract off 2 times the area of these rectangles, 48. And that will give us 96. So we've got 352 minus 96, or 256 square centimeters. So there are different ways of doing this as well. So let's keep our 256 up here. The other thing we could do is, instead of boxing this in, is we know we've got this triangle. It's 8 centimeters there. So we've got 2 triangles that are 16 centimeters with a base and 6 centimeters with the height. That means we have 2 times 1/2 the base, which is 16, times the height, which is 6 of these triangles. And then we have to add in, remember we are told that each one of the sides are 10 centimeters. We've got a rectangle in here that has a width of 10 and a height of 16. So now we're going to get 16 times 6, 1/2 twice that, so we'll end up with 16 times 6 is 96, plus 10 times 16, which is 160, we'll end up with 256 square centimeters. So the whole idea is there are many different ways to find these areas, and we can use what we know about triangles and rectangles, cut them apart into different shapes, and then add them back together, or fill in, make a big rectangle and subtract off areas of different shapes that are triangles and rectangles, and we'll end up with the same answer.